Welcome to this tutorial on implementing car physics in 3D environments. Today, we'll dive deep into the mechanics that make a virtual car feel real. Whether you're a game developer, a simulation enthusiast, or just curious about physics in gaming, this tutorial is for you. Let's start by understanding the basics of car physics. A car's movement is influenced by several factors, including acceleration, braking, steering, and friction with the road surface. To simulate this accurately, we must consider forces acting on the car, such as gravity and inertia. First, let's set up our environment. Open your favorite IDE and create a new project. For this tutorial, we'll be using Java along with the JMonkey engine. Make sure you have the latest version of JMonkey engine installed. Next, we'll create a base class for our car. This class will contain essential properties like speed, acceleration, and direction. Let's code that now. In this class, we have three properties: speed, acceleration, and steering angle. We also have methods to accelerate, brake, and steer the car. This is a straightforward foundation, but we'll build on it significantly as we progress. Now, let's implement the movement logic. We need to update the car's position based on its speed and change its direction based on the steering angle. Let's add a method to update the car's state. In the update method, we update the car's speed using the acceleration, then compute the new position based on the speed and time elapsed since the last frame, TPF. We also calculate a simple steering movement, resulting in a new position based on the car's current steering angle. To demonstrate our car's mechanics, we'll integrate these physics updates into the game loop. This means updating the car's state every frame. Let's browse to the main application class. In the simple init app method, we create an instance of our car class. In the simple update method, we call the car's update method to apply our physics calculations every frame. Let's implement user controls to drive our car. We'll need to listen for keyboard input to control acceleration, braking, and steering. We can do this using JMonkey Engine's input manager. In the code snippet above, we map keys W, S, A, and D to our car controls for accelerating, braking, and steering left or right. We also implement an action listener to handle key presses and adjust the car's properties accordingly. Now that we have controls to drive our car, let's tweak some physics parameters to achieve more realistic behavior. A crucial part of car physics is the friction between tires and the road. We can simulate this with a simple friction model. Here, we apply a simple friction model by multiplying the speed by a friction coefficient each frame. This simulates the braking effect and reduces speed gradually over time when the car is not accelerating. Next, let's discuss how to handle jumps and bumps in the terrain. We need to account for the vertical movement of our car. We can do this using a vertical speed property. In this snippet, we add a vertical speed variable. When we invoke the jump method, we set an initial vertical speed, which decreases over time due to gravity. We add this vertical movement to the car's position during the update cycle. Now, let's incorporate realistic terrain handling. We can do this using raycasting to detect the ground under the car and adjust its height. The checkground method casts a ray downward from the car's current position. If it collides with the ground, we adjust the car's vertical position to match the collision point. This gives a basic response to terrain changes. Let's update our update method to include these checks for terrain and vertical dynamics. By incorporating the checkground method, the car reacts to terrain changes in real time, giving players a more immersive experience. But we need to refine our physics further by implementing traction control. Here, we simply cap speed to a maximum value. This can be adjusted based on different factors like tire conditions, vehicle type, and surface type for more realism. Now let's visualize our car's motion. To make this more interesting, we can create a simple 3D model of our car. In JMonkey Engine, we might use a pre-made model or create our own using Blender and import it. After loading our car model, we set its position to match our physics calculations. We also need to update its position in every frame to reflect any movements made by our physics calculations. Now run the application. You should see your car model now moving on the terrain as you control it with the keyboard. As you accelerate and steer, the physics system should give a sense of authenticity to the movements. Finally, let's talk about refining this further with advanced techniques like tire force models, suspension dynamics, and even destructible environments. The basics we've implemented here are fundamental to building more complex systems. To conclude, you now have a solid foundation in implementing 3D car physics using Java and JMonkey Engine. Don't hesitate to tweak the parameters and experiment with additional features to make your project unique. Thank you for watching. Please like and subscribe for more tutorials. Let me know in the comments what features you would like to see implemented next.